So, what we want to be able to do, this is what we have talked about a number of times. So let's look at the square root of 24. Okay, we want to simplify this. So, the previous one was a bit like just trying to combine things together. But when we deal with this, what are we trying to do? Well, we're trying to factorize 24. There's that word again. But the only point in factorizing it is if we have a square factor. All right? So, long terms, the factors of 24 are 24 and 1, which are both pointless for us, right? But we have 2 and 12, 6 and 4, anything else? 3 and 8, and 6 and 4. Okay. Are any of those square numbers? 4. All right? That's the only one we're really interested in. So square root of 24 becomes the square root of 4 times 6. Right? Which from the law that we did before, you can split it into the square root of 4 multiplied by the square root of 6. The square root of 4 is 2. So it's 2 square root of 6. I could split 6. Why not? Why am I not going to bother? There's no square factors of 6. 1, 6, 2, and 3. No point. Right? Can't do anything with splitting it up, so there's no point. Right? So this and this are what? Equivalent. Good. Same thing. Just written in a slightly different. Alright?
And is 2 root of 6 actually more useful to us than just leaving it as root?
Because it has less.
You are going to be in a situation where this will not be your final answer. This will be a stepping stone to a final answer. So yes, having 2 there, because now if I want to divide by 2, easy, right? So yes, it's nice to be able to eliminate things. Like with the algebra we just did, it's easier to eliminate a 2 than it is a root 24, right? In all our elimination, if you think about eliminating with quadratics, a factorized form is what we want, right? Okay, now I did have a little question. I'm surprised Jacques hasn't come up with this there. Do I need to put plus and minus?
For what? The square root of 6 or 2 times?
Exactly.
No, when we actually solve.
But if I asked you what's the square root of 4, it's 2 and negative 2. So I've done the square root of 4, is it not 2 and negative 2? So should we not have plus and minus 2 root 6?
Or could we do x1 and x2, x1 being plus 2?
Plus minus 6 to the problem.
Okay, that's the simple answer to it. This is plus and minus 2. But this is plus and minus the square root of 6. Now, you will need to take this into consideration if it's applied in a given situation, right? If you need to take them to. But we don't worry about the plus and minuses when we're just simplifying with surds, because just like Cameron said, you've got plus and minus both parts. Yeah?
Yeah, if it was just 2, not 2 from, then it would be from.
Yes, exactly. If you end up with only the answer 2, you would have plus and minus 2. Right? So we don't need to worry about the plus and minus. All right. So these ones, as they get bigger, we just need to know our times tables. Yeah? Simple as that. If I don't let you use a calculator. So let's have a look at the square root of 991 with no calculator. What would be the process?
Not 3, not 9.
But it's smaller than square, which you can find even smaller.
Say it again, sorry.
Split it into numbers that you know.
Yeah.
991 and 1 are factors. Thank you, Liam. You could change it to 1 time.
It's impossible.
Yeah.
Why? Because you've just looked up the answers.
There's no prime factors.
Oh, 0.90.5.
Is that square?
It's 9. No.
Well, should we divide it by 4?
So when you try and do numbers, what you try and do is you try and divide a number by all the prime numbers in turn. So divide by 2. No. Can it be divided by 3?
No.
No. How do I know it can't be divided by 3?
Because there's a 1.
Because if you add,
21 divided by 3.
if you add all the digits and it's not divisible by 3, then
Yeah. 9 plus 9 is 18, plus 1 is 19. It's not divisible by 3. Okay. Is it divisible by 5?
No.
No. Is it divisible by 7?
this one's a complicated rule and I forget it, but probably not.
Let's assume not.
Why? 7's end in 1 sometimes, don't they?
If you
21.
subtract 21 from it,
Okay.
then you get
So 970.
70, and 97 is not divisible by 7.
Not like so it's 970.
Yeah,
Yeah, but whatever you would
you
get
would
from that
only
would
get
times it by
a
10.
number that ends in 0, that with one of the factors being 7,
If it was 7
if it's 7 times 10.
Okay.
7 times 1, 2, 3, 4, 5, 6, 7, 8, 9 do not end in 0.
True. So we're happy that divide by 7 is not going to be?
Yeah.
So next one would be divide by 11.
It's not divided by 11.
Not divide by 11. Divide by 13.
Probably not.
Probably.
17 is the next one.
Are you sure it doesn't divide by 13?
I don't think so.
The way you ask that.
I tell you what.
I'll check.
The way you ask that makes me think it is divisible by 13.
No, it doesn't.
Okay.
Jack.
Divide by
Division.
Well, I picked down my head.
17.
Okay. 13.
No.
No.
I forgot how to do the division.
Divide by 19? No. 19?
So quick as it is. Mental arithmetic. So quick.
No. No.
Super good at it.
23?
I picked
Now, guys, what we're introducing here is 991 a prime number.
No.
That's
Well,
what
yes,
I
it
said.
is.
Is it? I said before.
How do we know? Well, this is why
I know.
prime numbers are used in security of credit cards and things, because it's really difficult to prove if a number is a prime number. If you, as mathematicians, can come up with a way of determining that any number is prime with an equation, you'll be billionaires.
Isn't there like a
We've talked about that before.
hypothesis?
Pardon?
Isn't there a hypothesis that like graphs all primes?
I don't know. There probably will be, but it's one of those things. It's very difficult to know to prove. Yeah.
The next question is a single digit. It's pretty obvious that you will not be.
Yeah. So, do we think this one is not actually going to simplify it?
Yeah.
No,
Jack, what's the square root of 9? There's 91.
No, it's not.
No. Okay.
And anyway, at some point we don't need to search for that because it's not helping us do it quick.
So it does say. Does it? Oh, I don't remember. Let's do the square root of 675 then. That one definitely divides by 5.
25.
So that would be the square root of 5 multiplied by.
25.
No,
No.
I'm saying it divides by 25.
It does divide by 25. Yeah. So if we go straight for 25, that's nice. The reason is, well, 75 divided by 25 is 3. So 75 divided by 25 is 3. And then 600 divided by 25, well, that's 4 per 100. So
24.
24.
The 600 and then
So the answer is
27.
27. So we've now got
5 times 5 times 27.
27 lots of 25.
25 is square, so it's 5 root 25.
So we've got 5 root 27. Is that your final answer?
Yep. Well, I mean, can we
No.
break?
No.
Probably not.
No,
Because this is where,
Oh, no.
again, 27 is actually 9 times 3. So then we've got 5 times 3 times root 3. So we have 15 root 3.
That makes sense.
Yeah?
But isn't something times something? Oh wait, no, we're doing that inside. I'm sorry.
Yeah. Make sense? Alright, so we'll move on to the problem solving one. Let's have a look at 12.
What? What's
Oh, I think I might know what it is.
Are you sure it's almost impossible? Or-
No, it's. I think I know what it is.
Okay,
I'm probably wrong.
first off, we have 200
B.
multiplied by b to the power 4 multiplied by c squared. So what we can do with the law, we can just split it into 200
times B4
b to the power 4 times.
C
C.
squared.
So we've already got
C.
a c.
Is B cubed? Does that squared become B squared? Yeah, B squared.
That's b squared. How can I know that? Well, if you remember, b to the square root of something is the same as to the power of a half. Remember that one from your rules of indices? What do you do when indices are? You multiply them, yeah? So 4 times a half is 2. So we've got b squared. So this is b squared. Yeah.
Also, since there's one of the rules that says you can split it, it's b squared and b squared.
Exactly. B to the power 4 is b squared squared, and we're square rooting that. So it's another way to do it. Lots of ways to think about it. It's good, isn't it?
The other one is 10 root 2.
So this then we can see is the square root of 100 times 2. So 100 is,
10 squared.
so we've got 10 root 2,
Times
okay,
B squared.
multiplied by b squared multiplied by c. So just to write it using proper conventions, 10 b squared c root 2. Yeah? Easy enough? Writing it down?
Wait.
I need to start writing you a new
Mr. Potts, you
assessment.
resume the recording.
What?
Yeah, you resumed.
Did I do it again, did I?
The